Hi guys. So in this video we're gonna cover some content. Hopefully, I'm gonna try to keep it short. We're gonna talk about some of the uses of macros in Loox and the awesome things you can make with it. So one of the really cool features you can get is what are called pattern matching macros, which are macros that get expanded in the pattern matching macro, which is case, and they provide extra features for case, which are really useful. So what just happened? Okay, this is weird. Get some weird bug by Stack Overflow. Sorry, by GitHub. Whatever. We can kind of see the documentation here, even if it doesn't look so well. You know what? Let's just check out the code. So here we have some examples of this pattern matching macros. So as I said, pattern matching macros are macros that you invoke in the pattern expressions of your pattern matching code. So for instance, here we have this code for doing pattern matching on the list of tokens we receive for this piping macro. And here it's not that big of a deal that it looks like that, because we're not really doing that much. But let us say that instead we're doing a slightly more complicated parsing of the input tokens, like the one we do here. And this looks ugly. This looks terrible because of all the complexity here. But let's just focus on the patterns here, okay? So let's get rid of this. 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 And now we only have the patterns to take into consideration. Now remember, if you might remember from the previous episode in which I talked about macros and working with syntax and stuff, you might remember that this code is actually from pretty early on in the standard library, so we don't have a lot of the comforts that we get later, like the full-blown case macro or pattern matching macros. That doesn't exist at the moment in which this code was crafted. But how would it look like if we had that, if we could implement this in an easier way? Well, the first pattern matching macro that we're going to be seeing is just backslash. We basically, it checks out the code inside your pattern, and if there are any macros, it expands it. Now, when you want to do pattern matching lists, this is the correct way. I mean, forget about all these contents. These are not relevant. These are just the contents of different parts of a list, but just focus on the list structure. I mean, this is a list with 5 elements: 1, 2, 3, 4, 5, and then the empty list. I have to do a bunch of cons expressions in my pattern just to be able to get all those 5 elements. It's insane, and that's without considering all the syntax that I have to parse. I mean, I have to parse a tag here, a form here, and some arbitrary ASC tokens over here. That's too much. I mean, just imagine how to do that every time you need to do pattern matching of any kind. It's just madness. So how could we use pattern matching macros to make our lives easier? Well, turns out it's actually pretty simple. Let's say that instead of using this explicit list pattern matching syntax, we're going to be using the list macro, because the list macro generates the same syntax as this one, but for creating the lists. So list macros are used for creating things, not for destructuring them. But since it's the same syntax, because it's all cons cells that I'm generating and the empty list as nil, then why can't I just piggyback on the fact that the list generates the same syntax, but instead of using it for building a list, I can use this pattern matching macro to use that syntax for destroying the list or for breaking it apart. It's actually pretty simple. So all I need to do is eliminate the consing, the explicit cons cells, because I know that I'm gonna get all of that, and also the explicit list, so the explicit nil element, which list also generates for me. I can just eliminate all these things and just have this flat structure. Now I know that I'm trying to pattern match against the first element being this tag, the second element being this form, for which I can also use list, or rather list ampersand, which is a version that the last element is assumed to be another list, as in the case of this form. And notice that I don't need to put the backslash here, only here. And the reason is that pattern matching macros are only detected at the top level of the pattern. So if I did something like this and then put something like this, it wouldn't work. It wouldn't work. So instead, we do things this way. You put the pattern matching macro here, and then receives this. It expands everything, and then the output is going to be the real pattern, which is the one containing all the cons elements, which we can see here, which you don't want to write. So that's great, and we can convert the entirety of this. Now, mind you, at every pattern we're going to have to invoke this, because patterns work on pattern matching macros work on individual patterns. They don't work. It's not like you use a pattern matching macro and it's going to apply to all the patterns in your pattern matching expression. It doesn't work that way. And one of them, the reason is that by working on them by using them on an individual basis, you get more flexibility, because you can mix and match pattern matching macros within the same pattern matching expression, which is really, really convenient. Finally, we have this. So check this out, it's so much cleaner. So much cleaner. And this doesn't just work with the list macro, it's going to work with any macro. If a macro produces code that is, at the same time, the same code that you use both for building data structures and pattern matching against them, then you can just use it with this backslash macro and you're done. It's incredibly convenient. Incredibly convenient. But it's not the only tool. It's far from it. So it's like the most basic tool, I use it all the time, but it's not the only thing. Oh, finally we got this here. So check this out also. This is another pattern matching macro. They're called OR patterns. If I'm not mistaken, I think standard ML has something like that natively, but here it's actually implemented as a macro. It's basically a way of saying, hey, so if you have this data structure and there are more than one possibilities for which you want to have the same result and you want to enumerate them, then you can use the OR pattern to say, hey, if it's either this pattern that gets matched or this one, do this. And you can even have other ones. I can say hey, if it's Saturday or Sunday, do one thing. If it's Wednesday or Friday, then do something else. You can mix and match as much as you want. And you can even you can even get arguments from that, because let's say that Saturday takes a Boolean value and Sunday also takes a Boolean value. I don't know. Maybe you count it. Maybe you're gonna count the Saturday or the Sunday as weekdays if you have to work on those days because maybe it's crunch time at your company. Well, you can also refer to those variables here. Let's call it free day, our Boolean variable. And if it's Saturday or Sunday, then we're only going to count it as weekend if it's a free day, if we don't have to work. And if it's not a Saturday and Sunday, then we don't need to have the weekday variable, because everybody works from Monday to Friday. I mean, not really. I mean, you have you can have vacation days or whatever, but let's keep this simple. So you can refer to variables within the OR expressions. Though, of course, if you're going to do that, then you're going to have to be working with variables that are common to the different cases. not all variables, but at least the variables in which you're going to be referring in the body have to be common everywhere else, because otherwise there will be a bit of a mismatch. So you don't lose any power with this. You only get pure convenience. It's really awesome. There's also the open macro, which we saw in a previous episode in which we were talking about signatures and structures. If you remember, there is the using macro for opening some structure like int number. There was another way in which you could say, hey, let open int number, and then do this. And the difference is that, the let macro in loops is implemented in terms of pattern matching. It's implemented in terms of case. So everything you can do in pattern matching, you can do with let, albeit with a little bit more limitations, because let works with patterns with single patterns. I mean, like in pattern matching, you can have multiple patterns. Like here, I have 1, 2, 3 patterns. But in let, you're only going to have one. But for working with records and tuples, one is enough for a lot of cases, so it doesn't matter. So this is a pattern matching macro, open, and I frequently use it to just open a data structure, open a structure within the rest of a let expression. So I can actually refer to the contents of this in here. I can make this foo be the same as 1020, and this function here comes from int number. So I can refer to that after opening it, and of course I can refer to it within the body of the let. And since I told you that the arguments of functions can also be pattern matched against, there's even an example here in which we have this function, this range function. If you give it an implementation of the enum signature, you give it an enum structure, and you give it some values, from which point to which point in the range of values that you want to generate, from which of those you want to go, then I'm going to generate a list of all the values in between. So I'm gonna get the less than equals and the suck or successor function from the enum. Then I have this from to limits, and then I have this helper range function, which is not defined here, that actually does the iterating and does the build up of the function, or of the list of values themselves, the range of values. This is an example of being able to use open in the position of an argument to the function. So you don't have to do it in let expressions, you don't have to do it necessarily in pattern matching expressions, you can even do it in the arguments you get. In the same way that our power function here pattern matches against a tuple of elements it receives right in the list of arguments, just like that. So everything you can do in pattern matching, you can do it even on function arguments. It's that powerful. It's that awesome. So we have seen this simple pattern matching macro expansion tool, the opening tool, or patterns. Here is slots. Slots is very useful when working with record types. You can basically say, hey, this record has these slots. It might have more than that, but I only care about these ones in particular. So create for me 3 local variables with the same names. If you're familiar with the Clojure programming language, that's like having a keys deconstructor syntax in your let expressions in Clojure. It's basically the same way, except that whereas in Clojure that is like custom functionality of the let macro, in here is just a pattern matching macro that anybody could have written. And all these pattern matching macros were implemented independently, and you can create your own. In fact, there are even some modules in the standard library that are not the Lux module, that are other ones that are coming much later, and they add their own pattern matching macros. Okay, so you can even make your own. All you need to do is have this shape. So it was like that, there are going to be macros that are going to receive a list of elements. The first element is going to be the body associated with the pattern, in case you want to do some transformation on that. And the rest is going to be the arguments, all of the arguments as a list of tokens to the macro itself. So in the case of this macro here, in this usage, this will be the patterns in this variable. You will receive those two tokens, and the body here will be this. And you can perform whatever transformation you want. You just need to make sure that when you return an output from your macro, it has to be in pairs. Okay, it has to be in pairs, and because you're gonna be generating new patterns and new bodies out of your pattern matching macro, and they can even contain other macros themselves. In which case, you're gonna get a recursive expansion of all those pattern matching macros. And finally, now that I have talked about being able to generate multiple outputs from the pattern matching macros, you might think, but wait, does that mean maybe that I can generate multiple new branches out of code? And the answer to that is yes. And there's even a macro for that. It's called \template. And this is like the pattern matching equivalent to the doTemplate macro that we saw earlier. And basically, it works the same way. It takes some parameters. Let's actually copy this code so that we can get some nice syntax coloring. So check this out. This actually comes from the code that's in the library when I have some code for working with types, with type data structures. There's actually a module called looks/met/meta/type, in which you can have some functions for printing types, doing some type-based calculations, like in this case beta reduction. And here, I'm actually using the \template macro to avoid repeating a lot of code. Like for instance, working with variants in beta reduction and working with tuples looks exactly the same way. All the changes is DAG. So why worry about this? Why worry about having this? About using this? Wait. Oh, this code is actually. Oh, sorry. It's actually old code. It's actually old code there. That's why it looks funny. The correct code it's actually been updated to the latest syntax of types. Here it is. So again, here I have this this function, this beta reduction. Sums and products are handled the same way. In fact, not just sums and products. Sums and products are actually even handled the same way as lambda and apt. So I can make this even more economical. Yep. So check this out. I have this code for handling the pattern and doing the transformation, and I only need to write it once, and it works for all these cases: sums, products, lambdas, applications. The way you handle beta reduction in universal quantification and existential quantification is the same. So again, I have this \template. I only have to write the code once, and then I parameterize it. It's so convenient. It's so useful. It's amazing. It is great. So by using this code, by using this macro, I can avoid a lot of repetition in my pattern matching, and that means huge savings and avoiding a lot of errors because the macro is generating code for you, so you don't have to worry about what happens if I make a mistake, what happens if I make some blunder, if I forget something. You don't have to worry about that because the macro makes sure the code is just as you want it. So I also wanted to talk about advanced macros, but I guess for today we have talked about macros for quite a while. We have talked about that for 3 days by now. So let's leave advanced macros for later. Well, it's not really advanced macros. It's called more like composable macros. So let's talk about that later, because right now this video is probably a little bit long already. Yes, it is almost 20 minutes. So let's leave it for that. And at some other day, we're going to talk about composable macros, because I don't want to get you guys too tired about macros. So we're going to be talking about some of the other things that Lux has got to offer. And for some other day, we're going to talk about composable macros, resume or talk about macros in a more lightweight manner. So for now, this is it, and see you later.